Assalamualaikum warahmatullahi wabarakatuh. My name is Mohamad Razif bin Abd Rahman and I'm from the Faculty of Mechanical Engineering. And today, I will do a presentation of my proposal slide of my final year project. The title of my FYP is the effect of different calcination temperature on the properties of the hydroxyapatite bioceramic derived from chicken bone. Let's start with the project summary. Due to its chemical similarity with bone tissue, the project intends to investigate the development of hydroxyapatite bioceramic from natural waste, specifically chicken bone. The goal of this project is to convert calcium oxide that found in chicken bone and turn it into HA nanopowders. In order to achieve this, HA will be synthesized through calcination process method. Then the characteristic of the HA will be analyzed by using thermogravimetric analysis, X-ray diffraction, Fourier transform infrared, and scanning electron microscopy. All the analysis will be carried out to identify the properties of HA based on different calcination temperature. The project begins with the collection of chicken bones from any possible waste before synthesizing it. Move on to the next slide. For the introduction, over the past 50 years, there has been intensive study to improve medical materials, particularly used in skeletal repair and reconstructive surgery. Some materials that is widely used to support bone tissue are including metal, ceramic, composite, and polymer. Bioceramic has similarities to compositional with bone, so it is often used as an implant materials, and calcium-based phosphate, bioceramic has a high biocompatibility and excellent chemical stability. It was also found used as an implant material. Hydroxyapatite calcium deficient hydroxyapatite, tricalcium phosphate, and biphasic calcium phosphate are the four primary types of calcium phosphate. HA widely used in the field of biochemistry and medicine, particularly orthopedics, dentistry, and plastic surgery. The current worldwide intense research and development activities are focusing on expanding the hydroxyapatite applicability. The material are expected to value approximately $2 billion by year 2023. We continue with the literature review. I already have separated it to a few subtopics, including the biomaterials introduction, synthesis of HA and natural source, and calcination chicken bone, and the last one is the pre-treatment of chicken bone. Let's start with the biomaterial. In a bone restorative surgery, both biodegradable and non-biodegradable implants are employed. This material can be used for permanent filler or tissue connection. Some of the characteristics of biomaterial used as an implant are non-toxicity, durability, biocompatibility, resistant to platelet and thrombus deposition. It is also a method of using synthetic bone graft alternative, physiologically active chemicals, and stem cells to treat bone problem. Biomaterials are essential because they may act as a scaffold to encourage cell proliferation and differentiation in order to improve tissue healing. In 1987, the European Society for Biomaterials defined a biomaterials as a non-biological materials that used in a medical device to interact with the biological system. Biomaterial definition has changed over time depending on the context. It is currently defined as a those that interact with the biological system to evaluate, treat, heal any tissue or body function. We move to the synthesis of the hydroxyapatite. From natural source, producing HA requires raw material which can come from either inorganic or natural source. The structural properties of HA will be affected depending on the material used. This is because the behavior of the precursor will change as the HA was heated. Based on the article written by Mohamad Razif, it mentioned that natural waste material are valuable for compound extraction and recovery. Specialized methods are needed to convert this material into useful resources. Moreover, HA is a thermodynamically stable and it is crystalline state in body fluid. For the calcination of chicken bone, to get HA out of animal-borne biowaste, the clean and crushed bones are treated with an acid or alkaline solution. This is to remove fat and protein before undergo the thermal calcination process. Acid-alkali pretreatment as well as calcining at 700, 800 and 900 degrees Celsius are carried out before they are used. To observe the physical and the chemical properties of HA, FTIR and SRD method are used. This is to identify the presence of HA. Scanning electron microscopy of SEM is a method used to observe the tiny structure of the HA particles, while thermogravimetric analysis are used to observe the thermal stability of the material. Okay, move to the pre-treatment of the chicken bone. By calcining chicken bone at a high temperature, inorganic HA is extracted. In calcination process, dry bone particles are placed in alumina cubicles and calcined in a muffle furnace to remove all the organic contents and leaving only pure inorganic HA. The bone are heated at 700, 800 and 900 degrees Celsius at rate of 5 Celsius per minute for 8 hours. SRD and FTIR reveal that by increasing the calcination temperature, it will increase the crystallinity and loss of organic ash association, and the last point is depletion of carbonate content from hydroxyapatite lattice. Next, I will talk about the problem statement. Food industry, specifically chicken bone waste, usually will be discarded without fully utilizing it. Chicken bone is one of the cheap bioresources from the hydroxyapatite. We also need to get relevant data on creating the materials that can properly augment association and biological function. Next, the problem statement is to find a synthetic bone substitute. For this case is HA chicken bone. This is because its remarkable bone regeneration capabilities. And next, to find a material that is cost effective that can be used in bone regeneration. And the last one is to identify how direct calcination could be used to create hydroxyapatite from natural waste. It is also to replace chemical source to solve related problem. The main objective of this project is to synthesize HA powders from waste chicken bone via direct calcination technique to determine the best calcination temperature to convert waste chicken bone to hydroxyapatite powders. And the last one is to study the chemical properties of the obtained HA powders derived from waste chicken bone and compare them to a synthetic HA. For scope of work, for this project is to create a bioceramic hydroxyapatite from biogenic waste. It is to create HA using direct calcination process. And the calcination temperature will be vary at 400, 500 and 600 degrees Celsius for comparison. Also, the experiment will be carried out at the FKM UiTM Shah Alam, Advanced Material Laboratory and Heat Treatment Laboratory. For the limitation of the project, this project has a short duration of less than 14 weeks. Laboratory must be reserved in advance due to limited space available. And also, there is limited equipment available. The process experiment must be conducted repeatedly before obtaining the purpose of the project. We continue with the methodology. Here are the full process of the experiment that need to be conducted. First, chicken bone were collected from various waste and need to be cleaned, rinsed and dried for several days. The dried chicken bone need to be crushed to smaller bits through crushing and grinding process. Then set them on ceramic heating pad. Next, the chicken bone are dried in the oven for 24 hours at 90 degrees Celsius, and dried chicken bone are crushed into smaller pieces again. The sample should be calcined in a carbon-light furnace at 600 degrees Celsius for 1 hour at a rate of 5 degrees Celsius per minute. Then, the HA powders are produced. To observe the characteristic of the HA powders, we use SRD and FTIR or SEM method. Finally, the examination of the data and the interpretation of the result is recorded, and we can begin with the report writing. For the expected result, students are expected to produce a powder from HA. Figures shown are the before, which is the raw chicken bone, and after the calcination process, which is HA powder. As shown in the graph, SRD diffractogram and the calcine sample was created at different calcination temperature and sintering process. Uncalcined sample has a wider peak, which results in poor HA phase crystallinity. Diffraction peak sharpened as the increasing of the calcination temperature. The higher the calcination temperature, a sharper and narrower diffractogram peak shows, which result in more crystalline. For the temperature more than 700 degrees Celsius, it shows an additional peak linked with lockite and magnesium. We can see that as the temperature increases, some HA turns into the TCP. Graphs shown are some of the kind that expected result that might be obtained by the student when conducting the experiment. We move to the last part, which is the project planning. As you can see, the blue color represents the expected time to be completed, while the green color are the actual time for the task to be complete. There will be more work done in FYP2 in the next upcoming semester before the final year project is complete. I think that's all for me. Thank you for your time and thank you.